to the practice problems video for motion in 3 space. Okay, so this question asks us to find r of t, an equation for r of t and v of t, given that the acceleration vector is given by t, 4, and that the initial condition for v equals 0, or v naught, this is another notation for it, is 3, -2, and r at time equals 0 is 0, 0. So this is another way to write r naught. Okay, so let's start with going back one step. So we're going to find our v of t by integrating indefinitely our a of t dt, and then we have this v naught here, which is also the same as v at time equals 0. Okay, so let's plug this in. So we have the integral of t, 4, and then a dt, and then we have our plus 3, -2. Okay, so then when we integrate, all we do here is get a t squared with a 1/2 in front for our first component, and then we're going to get a 4t, okay, and then we have plus 3, -2. Okay, so if we combine these together, we get for an overall equation for v of t, 1/2 t squared plus 3, 4t minus 2. Alright, so that's it for the velocity vector there. Alright, that was pretty simple, and we're going to do the same exact thing just one more time to find the position vector. Okay, so this is going to be the integral of, indefinite integral of v of t dt plus r naught now. Okay, so here we're going to integrate what we just found. So we have 1/2 t squared plus 3, 4t minus 2 dt, of course, and then plus this 0, 0. So at the end, we're basically going to be adding nothing, so we can just ignore that for now, or forever from this point on for this problem. Anyway, so then when we integrate, what we get is a t to the third, and then a 1/6 in front, 1/6 plus a 3t, and then we're going to have a t squared, so that means we have to have a 2 on the bottom, so 4 over 2 is going to be a 2, and then minus 2t. Okay, so this is our position vector, and again, our initial condition for that was that r at time equals 0 equals 0, 0. So that didn't really add any constants in there. Okay, so that's it for both parts, and now on to the next question.
Ich will nicht, ich schwöre.